Hi, my name is Ryan Langlish, and this is Ludo Lodge, a channel about sparking growth in your journey as a game designer. And today I'm going to be continuing my series of tutorials on the software nanDECK, which is a great, useful, and free program for creating layouts such as cards and tiles for games and generating it from Spreadsheet data. If you're new to nanDECK, I recommend starting with my introductory video, which I will link above somewhere. And I have a few other videos already in the series that may be worth checking out. But today we're going to be looking at how to actually make tiles in nanDECK. We've kind of focused on cards up to this point, but there's really nothing that prevents nanDECK from making tiles, which are very similar to cards. They might just have different dimensions or different functions within the game. And specifically, I'm going to be using the example of something very similar to the board game Carcassonne, which is a very classic early 2000s tile weighing game that probably a lot of you are familiar with. If you're not, don't worry, that's not going to really affect the usefulness of this tutorial. But in Carcassonne, there's a bunch of square tiles where you're going to be playing tiles so that they match up. The sides match with existing tiles on the table, and you kind of are growing this landscape of tiles that are being played out. And any given tile is going to match because it's grass to grass, or it's going to be city to city, or it's going to be road to road. And so you always have to match those things. You can't do a road to grass or a city. You have to connect things, and you kind of have these growing fields and roads that are winding around, as well as cities that are growing. And so we want to achieve something like that. There's also in Carcassonne these monasteries, I believe they're called, which are kind of like these buildings in the center of a tile that a road might go to, or it might just be in a field. And so we'll add something similar to that as well. And so essentially what we're trying to do here is create square tiles where any of the given quadrants, when I say quadrant, I mean like the left, you can kind of picture it like a triangle, the left triangle, the upper triangle, the right, and the bottom have a particular element, right? They might have a city in it, or it might have a road coming out of it, or any of these different things, as well as the monastery potentially being in the middle of the tile. And so when we're going to make something in nanDECK, we have to first kind of think, what is our spreadsheet data gonna look like? How are we gonna format it in order to give us the information we need to work with it in nanDECK? And so I'm gonna actually jump into Google Sheets here to show you how I broke this down into a spreadsheet. So here's my example spreadsheet, and you can see this first row here is kind of the titles of my columns, and I have left, right, top, bottom, and middle. And so that's simply having each column define which of the game elements is in that quadrant of our tile. And so if we look at this first example, it's basically saying the left side is going to be a city, like the left side of the tile would need to connect to a city. But then the right, top, bottom, and middle are all empty, which is just going to be our way of defaulting to open field, which is just going to be kind of a green background. And so we can put city in any of these, like this tile is going to have city on top, but not on the other ones. Then we also have road as a keyword, which is going to be our way of saying a road is what's coming out of the left side of the tile. So in this particular instance, if I kind of highlight this row, which if you remember how nanDECK works, every row is going to be a card or a tile. So each of these rows represents one tile. This is saying out of the left is going to be a road. So you can picture kind of from the left to the middle of the tile. And then out of the right is going to be a road. So this tile altogether is just going to be a road completely horizontally, bisecting it down the middle. And so this is kind of how our spreadsheet, and I just have some random examples set up here. We also, this middle column is what I'm using for the towns. So I'm calling them towns, the monasteries in Carcassonne. We're going pretty generic here. So this is just going to say whether there's nothing in the middle or there's a town. We obviously could add more things to this. There could be other types of entities that show up in the middle, or there may be other keywords besides city, road, and town. But for now, this will give you the basic idea. So this is what we're going to be working with in nanDECK. And essentially what we're going to need to do in nanDECK is draw certain things based on what we have for each of these columns. And this is actually going to be a very good example, once we get back in nanDECK, of what kind of in programming we would call conditional formatting, where you have conditions on when certain things are going to happen. So think of something like, if the left value is equal to city, then we're going to draw city on the left part of a tile. that's going to be kind of how we build out this whole thing, is a bunch of these conditions of if this, then add this entity to the tile. If this, add this other entity to the tile. And that allows us to be pretty flexible with how we do things. So once you have everything here, you would go up to File, Download as a CSV, comma separated values, and then you want to place that in the same directory as your nanDECK text file. So let's jump back into nanDECK. So anytime we're starting a nanDECK file, the first thing we're going to want to do is link it to our spreadsheet. So we're going to use the link directive, and I simply, in the same directory as this tiles.txt file, I have my CSV, which is called tiles.csv. So that's what's going to link it to it. And actually, we could validate that. And if we build, we should see, even though our cards are completely blank, we should see it populate a number of cards equal to the rows in our spreadsheet. So that's kind of a quick sanity check. Yet we got 13 of these, which is how many rows I had in my spreadsheet. The next thing that I usually do anyway is I change the unit to inches. The default is centimeters. I guess my mind thinks more naturally in inches coming from the US, as much as the metric system is superior. You can do whatever's most comfortable for you. But what I'm going to do here next is set the card size. So normally when we've been working with cards, we've been using kind of a standard rectangular card shape. But here we want squares, right? Because these are actually going to be tiles. And so we want to define the card size. You can see card size here takes a width and a height. I'm just going to do it 1 by 1, 1 inch by 1 inch. Those are pretty small. In practice, you would probably want to make them a little bigger than that. But for the example, that's going to be all we need. So another thing in nanDECK is whenever you're providing these directives, so say we want to draw something like a rectangle or an image or something, you always, the first argument or parameter is going to be the range that it applies to, which is saying what range of cards in the spreadsheet does this directive apply to. So you could say like only cards 1 through 10 have this certain directive apply, which is useful if you have different types of cards or just different formatting for depending on what different cards you have going on. And I should mention, actually, before we get too much further, in my previous examples, we've used the visual editor a lot, which is a really good and quick way to draw up the visuals kind of in a, for lack of a better word, visual editor, instead of having to type everything out. For this example, I'm actually going to stay completely in the text editor. One, because I think it's a good example of kind of how to work in the text editor without using the visual editor. And this example just maybe lends itself a little better to that since we're going to be using a lot of that conditional logic. So at this point, we could validate the deck, we could build the deck, and you can notice that our preview changed to squares here because we now have a square card size. So that's great. But I was mentioning that all of the directives are going to want a range of cards. And so what's kind of a common thing to do, if we want all of our directives to apply to all the cards, is we might define essentially a variable for that range. So we're saying all in this case is going to equal 1 through, so the ranges are specified kind of like this, like 1 through 5. But then the way we're going to get kind of the total number of cards is kind of this bracket notation and then parentheses around just one of the column names we have. So I think our first column is named left, and you'll notice it actually highlights it red here because it recognizes it from our spreadsheet. At least I think that's why it's highlighting it. It's not just like a default thing. Let's see, does middle recognize? Okay, no, I'm lying to you. It's saying left because left must be just a nanDECK recognized keyword. But what this is doing, and you don't need to worry too much about this, I don't know exactly the formatting. I just know that this is essentially defining the range of all of the cards, and I'm storing that into this variable. So for all my other directives, I can just use this variable to represent all the cards. You also can technically leave the range directive blank. So, suppose I was doing something like rectangle equal to, and the first thing it's asking for is a range. I could just put a comma and go to the next one, and because I didn't provide anything, it would apply to all of the cards, which is often actually what I've done because I'm lazy. But I think this is kind of the recommended practice. It's a little more explicit and reads really well that like this is applying to all the cards. And if we had different ranges, we could define different names for the different ranges. But I digress. let's talk a little bit about how we're going to approach this. So the first thing I'm going to want to do, because we're going to draw everything. I'm not going to pull in any images. You could do this with images. Like I could have made images for all the different things that I was going to draw and then use the image directive to draw them. I'm actually going to use nanDECK's like shape drawing functionality to just draw very basic prototyping graphics. But the way it's going to work when we're using those drawing directives is it's going to draw from back to front. So when nanDECK's going through and just going down the file, anything that comes first is going to be behind the directives that come later. So we kind of want to think in that order. And so the first thing I'm going to want to do is I actually want to put down our green background, because green's going to kind of be the background of the tile, and then all the roads and cities and everything are going to go on top of the green. So the first thing I'm going to do here is I'm going to use the rectangle directive, which you can see takes a whole bunch of different things. For range, we're going to do all. And then we basically want a green rectangle that's going to take up the entire tile. And so we have the position X, position Y is going to be where the top left corner of our rectangle is. So I'm going to make that 0, 0, because 0, 0, as far as coordinates, is going to be up in the top left. And then we have a width and a height of the rectangle. And in this case, we want it to be 1 by 1 so that it goes completely over our 1 inch tile. So at this point we have a color, and then I think this is the color of the fill. So I think this first one is the color of the outline, and then the color of the fill, which you could do empty if you wanted it just to have an outline. In this case, we're going to do it filled, and I have a greenish color here, which is 98D, 98D. And you can actually see the second we type in a hex value, nanDECK will preview that color, which is nice. So that's a nice pleasant green. So then I'm just going to copy this and use the same one for the fill. Anytime you see these in italics here means that they're optional, which actually raises a good point of whether we need this one. Let's find out. So let's validate and let's build it. Look at that. All of our tiles are just green squares now. It's beautiful. But I'm curious, because this second one is optional, I'm curious what it defaults to. If we do this and we build, it still works. So actually, this is probably the better way to do it. Just do that. Whereas if we wanted to make it an outline, we could do empty here. And we may need a thickness. Let's say it was like... Remember, this thickness is in inches, so we don't want a very big number if we're going to have a thickness. Okay, maybe a little bigger than that. But this is just an example of just kind of playing around with the rectangle if we wanted to have an outline with not a filled-in rectangle. But in this case, we don't need either of those, which makes sense because the first one that's listed here is HTML color. So I think it always defaults to the first value instead of the empty as the second value. So at this point, we have some nice green grass. And now we want to draw some things on top of it. Now this piece, the green background, is consistent for all our tiles, right? Every single tile is going to have that green background. But this is where we start kind of varying, is the rest of the tiles are only going to have certain things drawn if those columns have those entities defined for that. And so this is what we're going to get into conditional logic. If you've done any programming or are familiar with programming, you're probably very familiar with if statements, which is kind of the basic conditional flow unit that you use in programming. And nanDECK, which is functioning much like a programming language, it's really executing your code line by line to then generate these layouts, has basically the same structure. We have an if statement. And so if we type in if, we actually see it highlights as blue. And the syntax for this in nanDECK is going to be if and then equal. We're saying like the if statement is equal to, and then we're going to have some value, then an operator, and then another value. When I say operator, I just mean like equal to or greater than or not equal to. Like we're what kind of thing are we comparing between these two entities? So we're going to start with figuring out the cities. And for our cities, we want to, like, let's say the left value had a city. I'm going to want to just draw a triangle in this quadrant, kind of like this. so that the whole left side is city, but then none of the other sides have city. And so you can imagine if we had like the left city and the top is city, those two triangles would kind of combine to make this bigger triangle that connects those. And that'll make it so that if you were putting these tiles all together, it would combine into this larger shape of the city, which is essentially what happens in Carcassonne, just with nicer finished graphics. But usually if you're working in nanDECK, you're in more of the prototyping stage where we're going to be tweaking data and regenerating our cards. And so I highly recommend not worrying about graphics too much at this stage. Once we have it all balanced and all tested and everything, we can make it look pretty later. Or have somebody else who has more skills in making it look pretty, later. So what we're going to do here is we want to say if the left column, our left value, is equal to city, we want to draw that triangle on the left there. And so we're going to say if left, anytime you want to grab the value of one of your columns, you're going to use these square brackets. And you'll notice that the second I type that in the square brackets, this populates with what it's seeing in our spreadsheet. Like this is literally our spreadsheet data for that left column, which is pretty nifty. And we're going to say if that's equal to, and then in quotes, I'm going to put city. So that's what we're asking. We're saying, is our left value for this particular tile, which is a row in the spreadsheet, equal to city? Whatever we want to happen there, we're going to put inside of that. And then there's going to be an end if. So these are kind of defining the block where everything inside of this block is only going to happen if left is equal to city. So what do we want to have happen? And it's pretty standard to indent in so that it's kind of easier to read these blocks. Because you could have nested conditional statements. I could within here have another if this, and that would only happen if both the things are true. So you have kind of a lot of control over what you're doing here. But we want to draw a triangle. Fortunately, nanDECK has a triangle directive. So we're going to say triangle, our range is going to be all, just as before. And if we look at the parameters down here, it's got position x1, y1, x2, y2, x3, y3. And those are literally just the coordinates of the 3 points of this triangle. And so let's think this through. We want the first point to be at 0, 0, right at the top. We want the second point, and we could go in any order here, but we'll say the second point is this one, which is still 0 for x, but it's going to be 1 for y. And then we want smack dab in the middle, which is going to be 0.5, 0.5. And then we're going to want to define a color. And similar to up here, we just need to define the first color since it'll default to filling it. And I'm going to use this nice brown color that I had used when I figured this out earlier, which I believe is that. Yep, there we go. Nice brown. And so what we're saying here is if left is city, we're going to draw this triangle. Otherwise, it's not going to. So if we go to here, we can see that the left value has some that are set to city. So when we run this, we should expect these couple that are set to city to draw that rectangle. So let's test it and see if that does what we want. Oop, oop, look at that. First one right there, it's a beautiful brown triangle. I highly recommend, especially when you're working in the code editor, because when you're working in the visual editor, you're immediately seeing exactly how it's going to look. If you're working in the code editor, you want to have a pretty good iterative process where you're putting something in, testing it, seeing if it's what it looks like so that you get everything right before you start adding more on top of it. So we kind of verified our triangle looks like we want it to, and it only does it when the left is city. So the rest of them are just green for the time being. But if you've played Carcassonne, you already, functionally, this is essentially the equivalent of a tile in Carcassonne that just has a city on the left side and green on every other side. We now want to repeat this process for each of the other directions. So if we copy this and go down, we want to say if top, I'm just going to kind of go clockwise around. If top is equal to city, it's still going to be 0, 0, but now it's going to be 1, 0 for this corner, and then still 0.5, 0.5. I don't know if top has any cities. It looks like it does. So we should be able to validate, build, and we can see that some of them now are showing on the top. Pretty easy to then finish this out here. We want right, which is now going to be 1, 0 for the top right. Then we're going to have 1, 1 for the bottom right. The middle, it's always going to be the middle for 0.5. And while I'm at it, I'm going to do bottom. Bottom. And that is going to be 0, 1 for this guy, then 1, 1 for this one, and 0.5. So if we validate that and build it, I think we have a city in every direction in our file. Yeah, look at that. That does. So you can see how these combine, right? This one happened to have city for all 3 of these, and so it combined it all together, which again looks like one of the tiles that you would see in Carcassonne. So that's pretty cool. We have, pretty simply there got that working. But now the next step is we want our roads to also appear, which is basically going to be the exact same process. We're going to have these conditionals of if the left, top, right, bottom is equal to road, then we want to draw our road, which is just going to be like a rectangle that goes to the center. So let's go ahead and let's say, and actually, this is your friendly reminder to save. Because nanDECK, you're editing a text file, but it's not saving it until you click save. And nobody likes losing work. So, save. Next, we want to repeat this process, but for roads. So we're going to say if left is equal to, man, I can't type, road. In this case, we're going to use a rectangle. What is it doing? It's like trying to autocomplete on me. It's throwing it to the side. Okay. Rectangle, we're going to do all. But we essentially want a rectangle that's like, I'm going to say 0.2 wide and kind of going here. And so we're going to have, for the purposes of left, it's going to come down to 0.4 and 0.6 is kind of my points for the y values. And then I'm going to use 0 as the x, and then I want to go a little bit past the middle to 0.6. And the reason I want to go past is like, if we have a road on the left and a road on the top, we want those to connect into kind of an elbow shape. And so I want those to overlap each other. So I want all the roads kind of overlapping this center area. So the values I've got here is 0. Man, it wants to autocomplete, and it's kind of driving me crazy. 0, 0.4. So that's what's going to bump us down. And then our width and height, our width is going to be 0.6. Our height is going to be 0.2. And then we need to pick a color, which I was just going to make them kind of gray. So if all our numbers are the same here, let's use that gray. Indent this in. Left, it looks like has some roads, so we'll be able to validate if this is doing anything. And look at that. We've got a road that goes nowhere. Let's see, do we have any cool examples that, no. Oh, there's a cool one. So you can see now how these are kind of working together. And this would be a road going into a city. And because our road is after city in the directives, it draws on top. So we kind of get this nice effect where it looks like it kind of cuts off the triangle, which it wouldn't really matter if the triangle was on top or the rectangle's on top. But it's a very functional, effective way of accomplishing that. So let's finish the rest of these. So we've got if top is equal to road, then we are going to, from 0.4 and 0, and don't worry if me going through these coordinates is making your head spin. I did it a little bit beforehand, and obviously you could play around with it. And if you run it and it isn't what you wanted it to be, you can change the values until you get it right. But now it's going to be taller than it is wide. Yep, I'll just do all of them and then we'll verify. Right is going to be, let's see, it's going to be, so it's a little confusing because it's always the top left of the rectangle that these first two coordinates are defining. So here it's going to be 0.4, 0.4, 0.6, 0.2. The other thing is if you're really comfortable with the visual editor and like this just like does not work for you, there's nothing really preventing you from doing it in the visual editor, which will then throw in code in this like visual editor block, and then going and adding these conditions afterwards. I've actually never tried that myself, but I assume that would work properly, that those conditions would be able to be applied within the visual block. But for now, we're just doing it in here. So we've got that one, and then our last one is going to be bottom road, 0.4, 0.4, 0.2, 0.6. And let me verify these all have road. I'm looking down here. I just want to make sure. So we should see a road in every direction. Look at that. So there's our straight across one that we were talking about. We've got some elbow ones. We've got a nice T shape. Another elbow. We even got a cross. So that's when all of them are roads. And there you go. That's a lot of the functionality. We're getting pretty close here to looking like the tiles that we would want. And obviously they all would match up if they were side by side. So really the last piece we have here in our simple example is the little village or town, I think I'm calling it, in the middle. That's kind of like the monasteries in Carcassonne. And it's going to be a similar concept. It's going to be if, this is like great conditional practice, like just how to use if statements. If middle is equal to town, then I'm going to draw like a little house. We're going to really work the drawing skills here with a square and then a triangle on top of it. So we're going to say rectangle. It's going to try to autocomplete and drive me crazy. And then we are going to, and I played around with this earlier. I'm not going to bore you with me trying to explain why these numbers. So this is just like a rectangle here. Let's see, the color I'm using is kind of an orange, I guess. So we've got a rectangle, and then we're going to do a triangle, a little roof. It'll be beautiful. And that's going to be 0.3, 0.4, because it's connected to our rectangle, 0.7, 0.4, and 0.5, 0.2. Let's not worry about it. Let's just go on with our lives. But I'm sure this will be just lovely. Middle, we can see we've got some values that are town here. Let's give it a roll. And look at that beautiful little house. You got the one that isn't connected to anything. And we got all of them here. So that's it, right? Like you can see how, we're looking at it very much from a Carcassonne style perspective. But if you were making any kind of tile game where the tiles connect together, like there's probably some similar concepts here that you could use, especially kind of using the conditions to determine what is going to be drawn. If we would print our deck here, we can see what they would look like in a grid. I could zoom way in here. And we can see all these different tiles. And then the beauty of nanDECK, and this is the whole point of nanDECK, is we do some testing, we try some things, and then we want to change things. We head back into Google Sheets. And all we have to do to add new tiles to our game is go and add new rows to our spreadsheet. So maybe we want one that is all cities, like every side is a city. Maybe we want one that has a town in the middle, but it's got like a road going in and out of it, kind of at an elbow. Or maybe we want one that like the left has a road and the top has a road, but then the right and bottom is a city. So there's kind of like an elbow road going past the city. We do all these different permutations here of whatever we want to be in our game. And then we go to File, we go to Download, and we're going to download the new CSV and then head back into nanDECK. And now back in nanDECK, we don't have to make any changes to our text here. We simply validate and build the deck, and that's going to pull in our updated CSV that I replaced in our folder. And then if we go, we can see we have, this looks a little weird here because our city kind of overlaps this. In Carcassonne, I think there's a little bit of green in between that. So, this could be improved upon, but you get the idea. But we got our elbow going through the town, and we've got this one that's completely a city. And so we added those into our set. If we went to print the deck or save them, we can see that they're all in here, and you could easily cut them out if you were doing a physical prototype, or perhaps you're using Tabletop Simulator, in which case I recommend my video on how to export from nanDECK into Tabletop Simulator easily, which I'll link above, or you could save up the images individually. So you got a lot of good options here from nanDECK. But that is all I have for this tutorial. Hopefully that was a good explanation of kind of more the tile use case of using nanDECK, and specifically kind of working more in the text editor and using some of these conditionals to achieve kind of different things for different cards that maybe wouldn't be obvious from some of the previous examples. If you enjoyed this video, give it a like, subscribe to the channel for more content like this, and I will see you in the next video.